Alright, so the current divider rule. So basically, the current divider rule is used to find current in branches of a parallel circuit. As in a parallel circuit, the current is split up or divided across each branch, unlike in a series circuit where the current is just the same throughout. So we use this equation in order to find the current in the branch X by finding the total current and then timesing it by the total resistance over the resistance of branch X. So you guys can have a look at this example I've got for you. So we have a parallel circuit just here with three different resistors. So in order to find the current in branch 1, what we would need to do is first find our total resistance, which we can do through this equation here. You end up getting 900.9 ohms as your answer. Now, because we have the total resistance, we can figure out the total current, IS, through a simple application of V equals IR, or in our case, I equals V on R, like this, to then get the answer of 11.1 milliamps. Now that we've got RT and IS, we can now jump straight into our current divider rule. So for branch 1, we want to use the resistor value R1 equals 1 kilo ohm. So we plug that all into the equation, like so, to then get an answer of 10 milliamps, just like that. Now, there is then a special application of the current divider rule you can use when there's only two branches within the parallel circuit. This can be very useful when they already give you the total current, as it makes it much quicker to solve, as you don't need to mess around by figuring out the total resistance. Because in this equation, in order to find the current of branch 1, you're going to use the total current, which is normally supplied when you would use this equation, times the opposite resistor of the branch you want to find, over the sum of the resistances. Now notice this is not resistance total, it is just R1 plus R2, which will be a different value. This is why this equation is generally better to use, because you don't need to find the total resistance. So in an example, you can see they haven't given us the total current here, so we still need to figure it out. So what we're going to do, we're going to find the total resistance, like so. You get 909.1 ohms. Then again, we're just going to use V equals IR, like so, to find that the current is 11 milliamps in this case. Now we can just plug in everything in order to find I1 again. Notice how R2 is used on the top of the equation. Now, it is very important you use the opposite resistor value in this circumstance, because otherwise you're going to get the wrong sort of value. You end up getting I equals 10 milliamps again. Alright, thank you for watching. Hope I've helped your understanding of the current divider rule.